Hey guys, let's solve the problem 5 and 3, finding bottom left tree values. Okay, so this is a really basic problem in which thing is, suppose I have a node here, here, and here. Okay, and the question says you have to find the bottom left, the most bottom left. Okay, so this is the most bottom left I can see in the tree. Okay, so this is be the answer. Suppose what suppose I have a node like this, and these are connected like this. Then the most leftmost would be this. Okay, and suppose I'll just remove this node, and now the most bottom left would be this. Okay, so we have to find first what is the most bottom level is. Then we will find the node that will appear first. Okay, so we are going down and we are checking like this, which will be the first node. And this would return the answer. This would be the answer. Okay, this is the main concept. So this question can be solved in a two form, either DFS, which could be tricky for more some of you, and there is BFS. Okay, first of all, let's solve the BFS, breadth first search. Okay, suppose I have a node here, 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 and like this. Okay. Now, in a queue, I will put, so let me just put A, B, C, and D. Okay, now suppose. And I start with a queue with A node in this. Okay, now I have only one node. So my result of most leftmost would be A. Okay, now with A, I'll pop this A, and in the queue, I will put the left and the right. Okay, I have completed this portion. Now I'll move to this portion. Now, which is the most first element? B. So I will remove A and put B in this. Okay, I'll pop this B, and for this, I have nothing here and nothing here. So I will just nothing do. I will nothing insert anything. Now I'll pop C. Now C, and there is no left, but I have a rightmost element. So I will put D in this. Okay, now I will move in this place. Now, since I have D, which is the most first element, so I will remove the B and put the D. Okay, this is the most basic solution. Okay, now let's code this up. Okay, first we need a queue which will store our root, and the rest will be root.val. Okay, and what we have to do, return this. Okay, in a queue I have put the root first. Now I have put the rest value as I have to put A first, then and iterate over the queue, right? Queue. Okay, now I need a flag that will tell me is it a first or not. Okay, this will tell me if the node is the first or not. Okay, then I need a size. Okay, while size, and I have to minus the size also. Okay, now let's iterate. Now I need a node, so I will put the node. Okay, I have to pop the element. Now if flag, then rest would be, if flag, the rest would be node dot length, and I will make the flag false. Okay, now if node dot left, then I have to append the node. and same applies for the right. Okay, that's all the code. And in the last, I have already returned the rest, and that's all. Let's run this. Yeah, it is been accepted. Let's submit this. Okay, quite efficient. This is my BFS. Okay, now if you want to learn about the DFS, then just keep on saying the video. And okay, another DFS. Now, suppose let's take this example only, and just remove all the things. Okay, now let's change. Suppose I am at A. Okay, now I will check. I have to check with the height also. I need a height h as a variable. Okay, now I will check. Did my h value is lesser than the current height? If it is lesser than the current height, then I will put a res equals to a. Okay, suppose in starting of this, I have h equals to minus 4. Okay, now I am at the current level of 0. So I'll check. Is 0 is greater than minus 1? Is it? Yes. Then I will put a in the rest. Okay. Then I will call the DFS of left and right. Okay. With height plus 1. Okay. Now same thing. Same applies. B. What is the height? 1. 1 is greater than 0. Yes. Then I put a equals to b. Okay. Now I can't call the DFS here. So I will just return nothing. Now I go for C. What is the height? Nothing. Now what is the height here? 2. Is 2 greater than the 1? Yes, this is greater than the 1. I will put D here. Okay. This is the main concept behind the DFS code. Okay. So let's, I need height minus 1 and self dot res equals to, I would say 0. Okay. And I just initializing it with 0. Okay. It would be the largest height I have ever reached in the DFS code. Okay, and this is the first no. Okay, and I have to return self.res. Okay, now let's make a DFS. I need a node and a height variable. Okay, now first call the DFS with the root and 0. Okay, 0. Yeah, I need a 0. If not node, then return just return from the function. Okay, now I'll check if self dot height is less than the current level I'm at, then I will put self dot rest equals to no dot left and self dot height equal to h. Okay, then I'll just simply call the node dot left and node dot right. Okay, these are the function. This is the function. A very small one, and let's run this. Oh, I left the second variable h plus 1 and h plus 1. Okay, yeah, let's run this. Yeah, it's been accepted also. And it's been accepted also. So this is the DFS call. and this is the BFS. Hope you understand about the concept. If your concept is clear, then just like it. Okay.